This massive gaming PC just came in my shop because, well, it's idling at 84 degrees Celsius. And if you try to do something as basic as opening up a web browser, well, you instantly spike to 100 degrees Celsius. That's way too hot. So what's causing these high temperatures? Well, normally when you see a case completely covered in glass, with just little slits for ventilation, and a side-mounted radiator that's set as an exhaust, that's blowing right into another glass panel and a hard drive, and probably can't breathe with all this dust inside of it, you'd expect one of those to be the issue. But that's not the case here, because I'm pretty sure this pump's dead. Because even though the system does register that there's something connected to the fan header, well, if you take one look at its speed at 7,000 RPM, you know something's not right. Because I don't know an AIO that runs that fast. And if it was running that fast, well, I'd surely feel it, but there's nothing running through these tubes. So that's our issue. But before we replace it, this system is filthy and I don't want this dust in my shop. So let's take this PC out back and blow it out. That's so much better. So now to go ahead and pull our AIO out, we can first pull off our pump block, then by coming around back, we can go ahead and unscrew, and then remove our radiator and fans. And although it sucks when an AIO fails on you, it's not that bad for our customer because I have some cool friends over at Fantex who sent over one of their Glacier 1 360 M25 Gen 2 AIOs for us to give away to the next customer whose AIO failed. And this is actually a really good unit because not only does it come with 3 of their M25 daisy chained fans, which simplifies cable clutter and makes installation that much easier, but this cooler also features a 4th fan on the pump block itself, which acts as a downdraft cooler for your VRM components. A little extra cooling never hurts there. And as far as installation goes, instead of installing it on this back wall, we're gonna install it in the ideal setup up top. And if you're curious why I say ideal, well, for most AIOs, installing your radiator up top actually becomes ideal because your pump is located in your CPU water block. And by having it installed this way, you can guarantee that your pump's at one of the lowest points in your loop, which is important because of air bubbles. See, over time, if you happen to have an AIO, the liquid that's inside of your loop actually starts to evaporate. And although manufacturers do things like having black sleeve tubing, which minimizes evaporation, it slowly still happens. And when it does, you may get a little air in your loop, which isn't a huge deal as long as it doesn't get to your pump, because that's where you get noise and eventually premature failure, because you're running a pump on air. But fortunately, because air bubbles rise, they're naturally always going to go to the highest point in your loop. In our case, that's going to be our radiator, which is why you want your pump always at the lowest possible point in your loop if you can, or at least never the highest. Also in this case, half of the radiator is not being blocked by this hard drive. With that said, with our new cooler installed, we can now go ahead and fire our system back up, where now thanks to this Fantex cooler, we're idling at just 29 degrees Celsius. And under a full load stress test, we're sitting 20 degrees cooler than our old idle temperatures with this dead AIO, which is probably cooler than this system's ever run. So